Another strategy we have is to solve quadratic equations by factoring, which is another algebraic way to solve things. And we use a really important property in mathematics called the zero product property. And it's simple but elegant. If the product of two numbers, say a and b, equals 0, then either a equals 0 or b equals 0. Right? One of those has to equal 0. And we're going to use that to our advantage when we solve quadratic equations, or an equation just like this. If we're multiplying a times b and we get 0, then I can break it down into either a is 0 or b is 0, similar to how we broke down inequalities, or those compound inequalities. And let's see what that looks like when we do example 1. So for our first example, we're going to solve the quantity 4t plus 1 times the quantity t minus 2 equals 0. And the two things we need to use the zero product property to our advantage is, number one, we need it to be equal to 0. And number two, we need it to be multiplication. So we can identify an A and a B, or even a C and a D, if it's all multiplication. So now let's take a look at what we have. So I can use the zero product property on this one because 4t plus 1 can be considered my A. And at the same time, t minus 2 could be considered my B. So I know that if 4t plus 1 times t minus 2 equals 0, then either 4t plus 1 must be 0, or conversely, t minus 2 must be 0. Okay, so both of these will work. So I have to solve each one individually. Let's go through that process. This one looks like it's easier to solve, so I'll start with the right side. I'm going to add 2 to both sides. I do that, I get t equals 2. And if I look back into my original equation, if I put 2 in for t, this becomes 2 minus 2, which is 0. So it doesn't matter that 4 times 2 plus 1 is 9, right? It doesn't matter what this is. If this is 0, then the solution works. Okay, so I just made that 0. But I also have to account for if this is 0. So I subtract 1 from both sides and get 4t equals negative 1. Divide by 4. And I have a solution of t equals negative 1/4. So my final solution for this one is that t can be negative 1/4 or positive 2. So instead of having to foil that and foiling that and then graphing it, I can use the zero product property because I know that one of those has to be equal to 0. And again, if I were to solve this by graphing, I would get the same answer. I would still get negative 1/4 and positive 2. But it'd be difficult to solve by graphing because the x-intercept is going to be at negative 1/4. It's really hard to see that grid mark unless you go by fourths. So then you'd be estimating. It would be kind of a disaster. So you have to look at your quadratic equation and figure out which method is going to work best. Graphing works great if your answers are always integers. It doesn't work great if you have decimals, because then you may be estimating, which is not good. On the left side, I want you to solve this problem. The quantity 3x minus 6 times the quantity 2x plus 4 equals 0, using the zero product property. In example 2, we're going to solve x squared plus 8x plus 15 equals 0. So let's think about, if we're given this situation, how could we solve it? We can't right away use the zero product property because the two things you need for that are 1, for it to be equal to 0, which we do have, but 2, it's got to be multiplication. In here, it's all addition. So I can't break this out and say this is 0, or this is 0, or this is 0. because it just doesn't work. If these two are both 0, this could be 15, and it would not equal 0. So it needs to be multiplication in there. So how do I go from this quadratic back to multiplication? And how we do that is we factor it. We're going to make factors. So we're going to use our X puzzle. Do we have any greatest common factors we can take out right away? Doesn't look like it. We don't have to slide because we don't have a number here. So we're just looking for factors of 15 that add up to 8. You think about that for a little bit. You should get 5 and 3. So I'm breaking this down into x plus 5 times x plus 3 is equal to 0. And now I have multiplication and set equal to 0, so I can use my zero product property to say that, well, either x plus 5 equals 0, or x plus 3 is equal to 0. And I solve for each of those. Subtract 5. X equals negative 5. Subtract 3. And x equals negative 3. So my final solutions for this one are x equals negative 5 and negative 3. And sometimes you might also see them listed in roster form. So negative 5, negative 3. You don't see it often right now, but when you start to get to higher level math classes, they often give answers to equations that have multiple solutions in a roster form. So negative 5, negative 3. In your book, you're going to solve the equation x squared minus 15x minus 54 equals 0. And check your answer with your teacher when you're ready to move on. Our final example is solving 4x cubed minus 21x squared equals 18x. So, as you know, I wanted to try and use the zero product property, but in order to do that, I need it set equal to 0. So I'm going to subtract 18x from both sides. When I do that, I'm left with 4x cubed minus 21x squared minus 18x equals 0. Kind of moved things over a little bit. So I want to try and factor this. It looks kind of complicated. I notice that I have an x cubed here. I have an x squared and I have an x. So right away I can actually take out the greatest common factor. So I'm going to take out an x. So use my upside down division and take out an x. And the result is x times 4x squared minus 21x minus 18 is equal to 0. So I do have multiplication. I can say either x equals 0 or this whole thing equals 0. But let's see if there's a way that I can shorten this up as well. Let's try and factor that. So you'll notice that I have a number here. So that means I'm going to have to use my slide, divide, and bottoms up. So I've changed this. So now it's x squared minus 21x minus 72, and then equals 0. And I'm using my x puzzle to find factors of negative 72, whose difference is negative 21. So let's think. Numbers that multiply to negative 72 have a difference of 21. Do you want to pause and think about it for a second? Or I'm just going to keep going. So the solution for this one is one that many people don't think about. It's actually negative 24 and 3. So let's keep on going through the process of solving this one. I still have my x here, and I've factored this to be x minus 24 times x plus 3, and all of that equals 0. Well, let's keep going down. I multiplied by 4, so I have to undo that multiplication. To undo that, I'm going to do my slide. My divide. So I divide both sides by 4. And this stays as x. This becomes x minus 6. And I can't reduce 3 over 4, so the 4 goes bottoms up, right? Becomes 4x plus 3 equals 0. So now I've got x times x minus 6 times 4x plus 3 could all equal 0. And I'm going to use my zero product property now. I know that I can label this as A. I can label this as B. So it's A times B. But I have a new addition now. I can also label this as C. So I know that either x equals 0, that's an easy enough one to solve, or x minus 6 equals 0, or 4x plus 3 equals 0. So I have 3 factors, which means I'm going to have 3 different possibilities. X equals 0 is already set. If I add 6 to both sides here, I get x equals 6. Here I've already gotten x equals 0. Subtract 3 from both sides. 4x equals negative 3. Final solution for this one, when I divide by 4, is x equals negative 3/4. So I've got 3 solutions here. I've got x could be negative 3/4, could be 0, or it could be 6. And so if you recall, I did say that if our exponent is 3, right, we're probably going to have 3 solutions. So that's how you solve by factoring. You have one example to do, or not example, but on your own problem to do on the left side. You're going to be solving 6x squared plus 17x equals 14. Have your teacher check your answer for this one, and all 3 if you hadn't already, and move on to the practice part of the lesson.